Hi, I'm Matt, and today we're going to talk about how to safely connect your PV Pi to your solar panel and your battery. With the PV Pi, there's a male XT30 connector for the solar panel and a female XT30 connector for the battery. The board is designed to connect to a 12-volt lithium iron phosphate battery. These batteries typically come in a few different terminal types. Typically, larger batteries have screw terminals, which connect via ring terminals. Smaller batteries typically have spade terminals. The PV Pi can charge a battery at up to 10 amps. As such, you need to ensure that all downstream wiring when connecting your battery is capable of delivering 10 amps. We recommend adding a fuse in line to ensure the cable is protected and fused at 10 amps. If your battery is not capable of charging at 10 amps, we recommend doing a few things. Firstly, setting up your PV Pi to limit the maximum charge current, and then additionally, adding a fuse in line at that appropriate lower charge current. Before plugging the battery in, it's important to test the polarity with a multimeter to ensure it matches the positive and negative that's marked on the PV Pi. Onto the solar panel. The smaller ones typically come with bare wires or a DC barrel jack. Larger panels come with MC4 connectors, which are widely available in hardware stores. There's multiple ways of physically connecting the cables for the solar panel and the battery to the PV Pi. One such is soldering wires in line. The other way is using Wago clips, which are an easy way of connecting up different cables without needing to solder. Once all your cables are set up, now it's time to connect your battery and your solar panel to your PV Pi. When you do this and you take your panel outside, the first thing you'll notice is the charge LED come on. This indicates that the PV Pi is currently charging your battery. After your battery is fully charged, you'll see the done LED come on, indicating that the battery is fully charged. A new charge cycle will start when the battery drops to 95%, which is about 13.3 volts. The fault LED on the board indicates that there's a fault occurring in the system. We'll talk about diagnosing the faults a little bit later in another video. One typical fault you may see with the PV Pi is an over temperature fault, which occurs if the board reaches above 65 degrees Celsius. The PV Pi has an efficiency of above 90%, but even still, at higher charge currents, this can still mean a notable amount of power dissipated in the board. Typically, you'll see the board be able to deliver a continuous 70 watts of charge at ambient temperature conditions. In hotter conditions or limited airflow, you may see the board overheat at lower powers. Adding good airflow via a fan in the enclosure and good ventilation can result in above 100 watts of charging without issue. In the next video, we're going to talk about how to communicate with the PV Pi over UART. Additionally, we're going to talk about how to install the PV Pi Manager and look at some of the PV Pi's smart functionalities, including battery monitoring and scheduling. Thanks. See you in the next one.